Hi, I'm Nathan Milhorn.
And my name is Inniyew, and our game is Dogfight. So basically, there are two airplanes in the sky, one controlled by each player, and you have to try and shoot the other plane down with your bullets. Uh, there is a score counter. Whoever gets to 10 kills first wins the game.
All right, and I will give, or we will give a demo how the game works. So both planes are controlled by separate players and they have their own flight characteristics. Um, and yeah, bullet collisions are handled separately, so a plane's own bullets won't kill it, but the enemies will. Um, Bullets also bounce, they do bounce off the ceiling and walls, but they don't bounce off the ground. And so the screen doesn't get cluttered. There's also a bit of random math going on when you hit when you collide with the ceiling, the wall, or the floor, just to introduce a little bit of interesting mechanics to the game. Um, One thing that I worked on primarily was the plane's flight physics. We wanted to make the flight physics of the plane as realistic as possible, or not as realistic, but um, as close to realistic as possible, and made sure that all of the sort of factors that would affect a normal plane's flight, we modeled, if not to like normal values, but to some extent. Um, so each plane can have separate. It can have separate gravity, can have separate coefficients of drag, coefficients of lift, different elevator uh, authority, different thrust, all sorts of things, which make it pretty fun and make each plane fly very differently. Um, so to start off with the move function, we calculate the effective lift and effective drag of the plane with our angle of attack, which we calculate using vector math, and the velocity vector and the z, which is our rotation relative to the ground. Um, so increasing your angle of attack increases your lift, but it also increases your drag. Um, so you bleed off a little bit of velocity, but you can turn quicker and stuff like that. Each plane also has mass, which also changes the flight characteristics. So a lighter plane will feel more snappy and will turn a lot quicker. Each cycle, we set our acceleration to drag because we have to reset the acceleration from the previous run because the acceleration can be calculated each cycle. Um, and that's how it works. And then after that, we add thrust, we add lift, we add gravity, and we add a small dampening factor, which just makes sure that there's no like oscillation or anything like that. Then we add velocity to, or we add acceleration to velocity, and we add velocity to position. We also handle the rotation, the pitch of the plane uh, separately, and that's its own. It's not just you hold up and you turn at a specific rate. It's also dependent on your angle of attack, your velocity, your elevator authority, your elevator angle, um, and that the up and down keys for each plane only affects the elevator request, which will then update the elevator angle. And then elevator authority is essentially how effective the elevator is, which is what we multiply by. Um, this is just to make sure that the numbers don't run off. Pretty simple. And This is what makes us bounce off the walls. We add a little bit of randomness, so you don't know what you're gonna do, so players will try to avoid hitting the walls to remain competitive, I guess. This is our direction vector, which we use to calculate our angle of attack, which we do here. Um, and yeah, self.I is a timer that's used for the firing. So we can change, um, like we can limit the rate of fire of the plane. This is our explode function, which makes the plane explode. It slows you down, and makes you unable to fire because the timer is negative. And it adds one death to your plane, which increases the opponent's score, and that is referenced in game. This is the elevator request function, which I described a little bit earlier. This is our firing function, which is a little bit interesting. Probably not the best way to do it, but it does work, and allows us to have um, rapid fire with that's not every frame. So if you're firing, it checks if I is greater than 10, and once it fires, it sets I back to 0, and the cycle will continue. And I gets modified in move. And yeah, that's my biggest contribution to the project.
One of the things that I worked on was some of the collisions between the objects and how we handle some of the rotating images. So basically, in Pygame, images are handled as rectangles. And because those rectangles are made up of pixels on the screen, those rectangles have to be either vertical or horizontal. They can't be rotated. And so what happens when you rotate an image is you get like this bounding box around the image that changes size, which makes calculating things like some of the collisions and also like the exact position of the center of the image difficult. Um, and so basically one of the ways that we got around this was by using masks for collision, which basically what a mask does is instead of using checking if rectangles are colliding like we did in some of our earlier Pygame examples, um, a mask is basically it looks at the image and it checks the alpha, which is basically the transparency of each pixel, and will only calculate collision between pixels that are not transparent. So all those invisible pixels around in the bounding box that's changing sizes as the plane rotates, those pixels get ignored because their alpha is 0. They're completely transparent. And only the ones that you can actually see whenever they overlap, the overlap is calculated, and we check for that overlap, and that's how we determine if two things are colliding or not.
Adding on to that really quick, our similar, just going off of that, because the image of the plane rotates like with the shifting, like the different changing size of rectangles, uh, that would be very, very weird to try to play with in the game. So we use this, which centers the image around the center of the image, and that's what we rotate around. Um, so the rotation is smooth, and it's very predictable and sort of makes sense. So yeah, that's our game, and hope you enjoyed. Hi, I'm Nathan, and I think that our project deserves an A. It was very, very challenging to get the physics working, and the most of what I did was the physics and also the rotation of the plane, which was probably the most challenging aspect for me. Um, we spent the longest on it, and we had a lot of bugs with the position of the plane running into the like infinity and overflowing and crashing like every 3 seconds. So that was fun. Um, that was probably the most challenging. We also had a lot of weird debugging issues because of the way we treated the instance variables, but we figured that out eventually. Um, I learned a lot about uh, Python, mainly that it's probably not the best platform to make a flight simulator. It's pretty slow when there are a lot of objects, but it works when we slow down our firing rate. And but yeah, that's what I think our project deserves.
My name is Inniyew, and I think that our project deserves an A. Um, One of the things that I helped work on with this project is a lot of the vector math that went behind some of the physics behind the plane and the bullet. Um, it was a little bit challenging to figure out exactly what we wanted it to do and how we would accomplish that, like mathematically. Um, Particularly trying to figure out um, like one example that comes to mind is the bullets facing in the direction that they're traveling. We had to figure out how to use the two argument arctangent function. And I think that that was an interesting element, was some of the math behind it. And another challenging aspect was the use of mask-based collisions. Probably the most challenging part of that was trying to navigate Pygame's sometimes messy documentation to try and figure out how everything actually worked. And that kind of taught me like the importance of documentation, like along with like even our own code. Like some of our code got big enough to the point where like at some points in the project we were like forgetting what some things did or forgetting what some things meant. And so that combined with like Pygame's documentation, I think one of the big things I learned is that keeping track of your own work and documenting everything is really good, not only for other people to use it, but also so that you can remember what you were doing.